In this project, the flow behavior passing through a porous medium is simulated. Studying fluid flow in porous media is one of the most widely used fields of science. A porous medium is made up of mostly perforated materials and contains pores and void spaces within itself. Various body tissues, such as the skin, bones, kidneys, and lungs, can be considered as porous medium. Porous media are widely used in a variety of industries, such as food, oil, textiles, building materials, insulation, filters, and membranes. In this project, fluid flow through a porous medium with three different porosities is investigated. The fluid domain consists of an upstream flow domain, a porous medium domain, and a downstream flow domain. In General Setup tab, you will see different dialog box from scale to units. By clicking on Scale dialog box, a new window will appear. In the open window, you may see the domain extents or the maximum value for each coordinate based on your geometry. Under View Length Unit, you may choose from different units available in this window, from meter, foot, inches. In the scaling part, you are able to change the mesh dimension based on your meshing software geometry you've used. For example, you've used the meter dimensions for your mesh. You can go ahead and change the scaling factors to meters, or you can change it into whatever units you want. For example, you can change it into feet, to inches, and so on. By clicking on the Check dialog box, you will see that in the Console tab, the Fluent software will start to check your mesh and geometry for any errors. By clicking on the Report Quality dialog box, you will see that in the Console tab, the Fluent software will start to check your mesh quality. For example, you will see that the Fluent software will give you the orthogonal quality and as maximum aspect ratio. You may double-click on the Display dialog box and a new window will appear, which gives you the ability to choose between the different parts of your geometry you want to show in the Fluent software. In the Appeared window, you may choose between different parts of your geometry to show or not show just by clicking on them. Also, the type of the solver is defined to be pressure-based, and the velocity formulation is in absolute form. The steady state simulation has been used, and the results are not a function of time. Also, the gravity is not taken into account. By double-clicking on the energy under the Models tab, a new dialog box will appear. In the Appear dialog box, we enable the energy equation since we want to know the temperature distribution along the geometry. The two-equation K-epsilon model with the use of a standard roll function is used in this project for analyzing the turbulent flow since it is robust, economic, and has reasonable accuracy for a wide range of turbulent flows. Our main material for this simulation is counted to be the air. By double-clicking on the air, a new dialog box will appear. In the Open dialog box, we are able to change the settings of our material. For example, in this dialog box, which is related to the air, we can see that the density and the CP, specific heat, thermal conductivity, viscosity, are shown. Since we are simulating the compressible flow in this project, we need to go ahead and change the density from the constant to ideal gas. After double-clicking on the part porous under the fluid cell zone condition, a new window will appear, enabling us to activate the porous zone option.
You can buy this learning product to obtain a geometry file, mesh file, and a comprehensive training video on how to set up, meaning the pre-processing, solution, processing, and extracting results, which is the post-processing and analysis.
In the 3D pressure contour presented to you in this slide, you may see how the pressure drops after passing the porous zone medium. Just like the 3D pressure contour, you may see the pressure drop here in the 2D pressure contour as well. In the 2D velocity contour, you may see that the velocity value near the walls are equal to 0, which enforces the no sleep boundary condition.
To benefit from Mr. CFD services, including simulation, consultation, and training, contact our experts via info@mrcfd.com.